Unit 1, Lesson 4, word problem number 5. So we've cleared our calculator, and here's our problem. You left Phoenix at 3 in the afternoon, 2 hours on the road. You have traveled 130 miles. After 3 hours on the road, you've traveled 195 miles. Algebraically create a linear model of the distance you have traveled over time. Okay, let me jump over to the next screen here and write this down. So after 2 hours, you're at 130 miles on the road. After 3 hours, you're at 195. I want to make sure those numbers are correct. Let's see if I can go back here. I cannot. Hopefully I got those correct. Let me actually look at the worksheet before I do the work to make sure that is correct. It looks good. Okay, so how do we algebraically show this without a calculator? Well, we're going to use the equation y equals mx plus b, and let's find that rate of change between the two given times. Remember that our initial time of when x is 0 is going to be at 3 p.m. in the afternoon. So when I have a 2 here, it represents 2 hours after 3. So this is at 5 o'clock and this is at 6 o'clock because it's 2 and 3 hours past 3 o'clock respectively. So how do we find the rate of change? We're going to take y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And I get 65 over 1. This is my rate of change between those 2 points. Let's see if I can go through and clear this. So 65 is my rate of change. And now we can use just some common sense here. So y equals 65x plus b. And in the past, I would have students that were really used to the procedural stuff. So they would take a 3, they'd plug it in, they'd plug a 195, they'd plug it in, they'd do all the work and they'd solve for b. But think of this, b represents the initial distance at your starting time. Well, if our starting time is 3 p.m., that's when we're leaving our driveway. How many miles have we gone? We haven't even left our house yet. So at 3 p.m., you've gone 0 miles. That's your initial miles at your start time. So I know based on common sense, it's y equals 65x plus 0. Now, if you didn't understand that, there's no problem with you taking either the first ordered pair or the second ordered pair. In this case, you would plug in 3 for your x, 195 for your y, you do the math, and you still end up with a 0. This is my equation. So with this equation, y equals 65x plus 0. At what time will you be in Los Angeles if you are 350 miles away? So it does not say we can't use a calculator here. I'm going to bring this up and I have y equals 65x plus 0. And you know what? We're going to come up to the windows. If x equals 0 is the starting time, let's go out 10 hours. Let's see what we have for 10 hours. Zoom fit, which is zoom 0. Okay, this looks like a good approximation. It does, let's see, is there a picture? Oh, we're not asked to actually fill in a graph here. So I have this down and I'm going to come back here. At what time? So I'm looking for x. X is always time. And I'm given a y of 350. So if I come over here, I'm going to go down to 350 and let's find out where do they intersect. Second, trace, hitting 5 and pressing enter 3 times. 1, 2, and 3. All right, let me write this down. X equals 5.3846154. What does this mean? Well, this isn't exact, a whole hour. So if x equals 0 is 3 in the afternoon, according to this word problem, 5 hours past that would be 8 o'clock, but then we have this partial hour. So I'm going to come back up here and type in 0.3846154 and take it times 60 because there's 60 minutes an hour. So we can assume, if I move this to the side, we can assume at 8:23 in the evening, you'll have traveled 350 miles away from home based on this model. Let's go to the next one. So this one says exactly 8 o'clock. So from 3 p.m. to 8 p.m. is exactly 5 hours. That makes it pretty simple. I'm going to come over here. I have my graph, second trace, and I go to value, plugging in 5, and we can assume 5 hours later, you are exactly 325 miles away from home based on this model. Okay, how many miles will you have traveled at 8:24? So I'm given time, which is an x value. When I plug it in, I have to ask myself, okay, from 3 p.m. to 8 p.m., that's a difference of 5, but then we get this partial time. And how many minutes are there an hour? There are 60. Second trace value, 5 plus 24 divided by 60. And we can assume you will have traveled 351 miles from home.